Hi there, folks. Today we're talking about the greatest common factor. And the greatest common factor, when we start talking about factoring methods, that's what we're going to get into today. The greatest common factor is the first thing you should always look for when you're factoring, all right? Even when we get into the more complicated factoring examples, you should always look for greatest common factor first. All right. So factoring itself, factoring is basically the reverse of the distributive property. Okay, so everyone knows our distributive property. We realize that the distributive property, we're multiplying by this thing. All right, so we distribute the multiplication. Factoring then has to be the opposite of that. To undo that process, we have to use the reverse operation. So to undo multiplying, just like when we solve equations, we divide. All right, so if the distributive property is multiplying in, factoring is dividing the thing back out. All right, and when you think about the distributive property, you think about things that kind of look like this. Like when you see something like this, that's a type of question you would use your distributive property on, and your answer would be a 2x plus 4. All right? But factoring is when we start with something like the 2x plus 4, and we end up with the 2 times the x plus 1. See, the distributive property is multiplying that 2 into the equation, and factoring is dividing the 2 back out of the expression. Okay, so let's talk about the greatest common factor. So the greatest common factor, we abbreviate it as the GCF, is basically the biggest thing that divides evenly into each term. All right, and that's not usually too much of an issue for students when we're talking about the numbers, but the variables are the thing that trip us up here. Remember that if we're dividing, when we deal with variables, we have to use the rules of exponents, all right? So just like our distributive property used the rules of exponents, when you multiply, you add the exponents. Factoring is going to use the rules of exponents. When you divide, you subtract the exponents. So as we start to look at variables, we're kind of going to look at it more from the perspective of the rule of exponents, say how many exponents do I have on this variable? How many am I allowed to take away? How many can I subtract? Because that's what division is for variables, okay? For example, if I look at something like this guy, I've got a 2x to the 5th plus 6x. So ignore the variable for a second. Just look at the number and say the greatest common factor. What's the biggest thing that divides nicely into a 2 and a 6? And the answer is a 2. So I could divide a 2 out. But now between the x to the 5th and this is an x to the 1st, think about how many x's, how many of those exponents I could take away before I ran out of x's in one of these things. You know what I mean? So the first one has 5 x's, the second one has 1 x. If I start taking away x's from each of them, how many can I take away before one of them runs out of stuff? And the answer is just 1. I can take an x to the 1st. As soon as I take an x to the 1st away from each of those, that second thing is going to run at x's. All right? And so that's kind of the way we think of it. We think of it almost like subtraction, because when we're dividing variables, we subtract the exponents. Okay? So if you want to just go right to thinking about it in terms of taking away those x values, that's okay. But now I set up parentheses and I say, okay, let me divide each of these. So like basically, I'm dividing this thing back out. So I have to do the distributive property. I have to divide this first thing by a 2x, and then I have to divide the second thing by a 2x. So that first guy, when I divide, that gives me a 1x to the 4th. Remember, when I divide, I subtract the exponents. The second thing gives me a 3 and an x to the 0, or just a 3 here, because the x's cancel. And see, that's factoring. It's just dividing the thing back out. So it's 2x times an x to the 4th plus 3. And you can easily check this by doing the distributive property. If you distribute, you'll be back to the 2x to the 5th plus 3. Okay? So again, think about the variables like you're taking them away, and you shouldn't have to show this step right here anymore. Okay? So watch, if I look at the next one. All right? The greatest common factor between a 9, a 3, and a 12, the biggest number that divides evenly into each of them is a 3. And now look at the x values. I've got an x to the 2nd, an x to the 4th, and an x to the 6th. If I start taking x's away from each of them, all right, how many can I take away before one of them runs out? And the answer is 2. I can take an x squared out, and as soon as I take away x squared, that first term has run out of x values. All right, so that's the most I can take away. And now divide it out. Ready? 9 divided by 3 is a 3. And then just think of it like subtraction. I had x squared, which is like 2x's, but I took away 2 of the x's, so I don't have any left. Here, 3 divided by 3 is a 1. I had an x to the 4th, which is like 4 x's, but I took 2 of them away, so I'm left with an x squared. See, it's my rule of exponents. I'm subtracting the exponents. And then this one, 12 divided by 3 is a 4. If I had x to the 6, 6x's, and I take 2 away, I'm left with 4x's, x to the 4th. It's my rule of exponents. I'm subtracting the exponents. And then the last thing I might do on this one is I might rewrite what's in the parentheses, because I like the biggest exponent going first, so the 4x to the 4th, then the minus 1x squared. You don't have to write the 1. If you write the 1, that's okay. And then the plus 3. Would it be wrong if you left it the way it was? No, this would be okay. I would accept this answer, okay? But most of the time you rewrite it like this. Just one of those weird math things, all right? But divide it out, all right? For variables, that means subtracting the exponents. If I look at the next one, again, between the 4 and the 24, the biggest value that divides evenly is a 4. And now look at the x's. It's an x to the 3rd and an x to the 12th. How many can I safely take away before one of them runs out? And the answer is an x to the 3rd. And notice it's always the smaller amount, okay? I can't keep taking away if one of them runs out. And now with the y's, here this is a y to the 1st and y to the 8th, the most I could take away before one of them runs out is a y to the 1st, is just a y, okay? And now I divide it out, ready? 4 divided by 4 is a 1. If I had x to the 3rd and I took away 3 x's, I don't have any left. If I had a y to the 1st and I took away a y to the 1st, I don't have any left. So all I'm left with at that first term is 1. And now 24 divided by 4, that's a 6. If I had x to the 12th and I subtract 3 from that, again, I'm subtracting the exponents. If I take those 3 x's away, that's an x to the 9th. If I had a y to the 8th and I took 1 away, that's a y to the 7th. And again, I'm actually dividing. It just so happens that that's my rule of exponents where I subtract the exponents, and that's it. And of course, I could rewrite what's in the parentheses. Let's not bother this time, okay? Just wanted to show you that in the last one. If I look at this guy, again, between the 5, the 15, and the 20, the biggest number that divides into all of those is a 5. Okay? That is a terrible looking 5. Let me try again. I can do better. I believe in me. Okay? And now between x squared, x to the 5th, and this one is an x to the 1st, the most I can take away before one of them runs out is x to the 1st. I can only take one x away from each of them. And then when I look at the y's, this is a y to the 1st, a y to the 2nd, and the last one doesn't have any y's. So if the last one doesn't have any y's, can I take y's away from all of them? No, I can't take any y's away. The last one doesn't have any. All right? So the greatest common factor is a 5x. And now let's divide. 5 divided by 5 is a 1. X squared, and I took one of the x's away, is an x. The y, I didn't take any of those away, so it just tags along for the ride. 15 divided by 5 is a 3. I had x to the 5th, but I took one away, so that's x to the 4th. Y squared, I didn't take any y's away, so it's still a y squared. Here, 20 divided by 5 is a 4. I had an x to the 1st, but I took one of those x's away, so I don't have any x's left. It didn't have any y's to begin with, so that's it. We're dividing the thing out. When we divide, we subtract the exponents. If I look at this one, between a 3 and the 7, the only thing they have in common is a 1, right? And between the x and the y, they don't have anything in common. I can't take x's away from each because one of them doesn't have x's. And I can't take y's away from each because one of them doesn't have y's. So all I can do is divide out a 1. 3x divided by 1 is a 3x. 7y divided by 1 is a 7y. Well, isn't that what I started with? Okay? And typically, we don't factor out a 1. If the only thing that can factor out is a 1, we call it prime. All right? Now, will there be a situation in which you have to do this, where you have to factor out a 1? Yes. All right? Which is why I showed that step, even though it's kind of silly. All right? But prime, remember, prime numbers are numbers that are only divisible by 1 in themselves. Okay? That's the same thing here. It's only divisible by 1 in itself, and we can see that here. Here's 1. Here's the same expression we had. Okay? And that's why it's called prime. It's just like a prime number. But there are situations in which we will have to factor out something, even if it's just a 1. All right? So recognize that. Even if it's prime, you can still factor out a 1. And then the last one here, between the numbers, what they have in common is a 2. and then between x squared, x to the first, and then the last one doesn't have any x's. So if the last one doesn't have any x's for me to take, am I allowed to take x's away? No. All right, I have to take the same amount from each. If one of them doesn't have any of that thing, I can't take that thing. All right, so all I can factor out here is a 2. 2 divided by 2 is a 1. 6 divided by 2 is a 3. And 4 divided by 2 is a 2. And that's it. All right, so greatest common factor is the biggest thing that divides evenly into each of them. All right, when we're thinking about that in terms of our variables, when we divide, we subtract the exponents. We're thinking about how many we can take away. And when I actually do factoring, it's just the reverse of my distributive property. I identify what can I take out, what can I factor out, what can I divide out, and then I do it. I divide it out. All right, I set it on the outside of the parentheses, and I see what's left when I divide and when I take away those variables. Okay?